Hi to everyone. I am Dr. VNSR Venkateswara Rao, working as Associate Professor from the Department of Freshman Engineering in Institute of Aeronautical Engineering, Hyderabad, Telangana. So today I would like to give the topic on surface coatings. So before starting the topic surface coatings, what are the contents involved in today's topic? The surface coatings involve mainly, first one is hot dipping, and second one is galvanizing, and third one is tinning, and the next one is electroplating, and finally electrolysis plating. So these are the methods involved in the surface coatings. So first of all, we discuss about the surface coatings. That means generally we know about the corrosion phenomena. Corrosion phenomena is nothing but a surface phenomena. In order to control the corrosion, we cut off the contact between the metallic surface with the surrounding environment. So that should be possible by the surface coatings. These surface coatings done by metals are called as metallic coatings. That means these are produced by the coating of one metal on the surface of the molten other metal. So that means the metal which is protected is called as base metal, and the metal which is coated as a surface of the base metal is called also coating metal. That means what are the methods of application on metallic coatings? That means metallic coatings are done by the following methods. So first one is hot dipping, second one is electroplating, and third one is electrolysis plating. Okay, so these are the methods on the surface coatings. First of all, we discuss about the hot dipping. Hot dipping is the process is applicable to the metals having higher melting point than the coating metal. So this is very important condition. Hot dipping mainly applicable to the metals having the higher melting point than the coating metal. That means base metal having the higher melting point and coating metal having the less melting point. That means it consists of a immersing well cleaned base metal in bath containing molten coating metal and a flux layer. That means the flux cleans the surface of the base metal and prevents the oxidation of a molten coating metal. That means what are the examples of hot dipping, like coating of zinc, tin, lead, aluminum on base metal like iron and steel surfaces. So most widely used hot dip processes are nothing but galvanizing and electroplating. That means galvanizing, tinning, metal cladding, electroplating and electrolysis plating are the processes involved in the hot dipping process. Totally 5 methods. So first of all, galvanizing. Galvanizing mainly involves the coating of a zinc on a base metal of iron. So that means galvanizing is the process which is the iron particle is protected from the corrosion by coating it with a thin layer of a zinc. That means at first the iron or steel is cleaned by pickling with dilute sulfuric acid at a temperature range of 60 to 90 degrees centigrade for 15 to 20 minutes. That means therefore it removes the any impurities like scale, rust and other impurities present on the base metallic surface. That means then after dipped in a molten zinc in the bath of 425 to 450 degrees centigrade to prevent it from oxide formation, the surface of the bath is covered with a flux like ammonium chloride. That means when the iron phase is taken out, it is coated with a thin layer of zinc, and to remove the excess of zinc, it is passed through a pair of hot rollers. Lastly, it is annealed at a temperature of 450 degrees centigrade and then cooled slowly. That means the galvanizing takes place in the picture diagram. Initially, we consider iron sheets from the left side. That will be diluted with sulfuric acid at a temperature 60 to 90 degrees centigrade and washing with water bath. After the drying chamber takes place, it will be two exits. One is hot air inlet outlet and hot air inlet for the drying purpose. After that, ammonium chloride flux is used in the molten zinc metal, which should be maintained at 425 to 430 degrees centigrade. Finally, you get a pair of hot rollers to get a galvanized sheet. That means protected from the corrosion phenomena. So this galvanizing is also takes place so many steps in the picture diagram: degreasing, rinsing, pickling, after that rinsing and the absorption of the flux solution and get drying purpose. Finally, zinc bath, nothing but molten zinc bath to get cooling and inspection process. So now we see what are the applications of galvanizing process. That means it is widely used for the protection of the iron exposed to the atmosphere, as in the case of the with roofs, wire fences, pipes, and articles fabricated from the galvanized sheets like buckets and tubes. That means galvanized ware is not used for keeping eatables because of the solubility of the zinc. Why? Because zinc is like a toxic metal and it is not suitable for a food industries. That means the popularity of galvanizing is due to the low cost of zinc. That means easy application and anodic protection offered by the zinc. So these two are the advantages of the galvanization method. One is the financially it having low cost and easily application on the anodic protection. Next we see galvanized images. It is the pure images. After that we get galvanized bolts. Next we see the second hard dipping process, nothing but tinning. So tinning is nothing but the process of applying a coating metal like a tin on the base metal of the iron. So that means the process of coating tin over the iron or steel articles to protect from the corrosion is known as a tinning process. That means tin is a nobler metal than the iron. Therefore, it is more resistant to chemical attack. In this process, at first iron sheet is treated in dilute sulfuric acid, pickling to remove any oxide film if it is present. That means tinning diagram is see on left side steel sheets present in the acid tank to remove the any impurities. After that it will be water tank for the action of a reaction. After that it will be dried in a hot air oven. There are two exits, one is hot air inlet and hot air outlet. After that it will be presence of a molten zinc because of the zinc chloride flux is present. That hot rollers faster to a pair of rollers in the presence of a palm oil. Finally, we get a tin coated steel material. So this is the process of the tinning. Now we see a cleaned iron sheet is passed through a bath molten flux, that means like zinc chloride solution, then through the molten tin, and finally through a suitable vegetable oil. That means lastly it is passed between the rolls to just the thickness of the thin layer, which may be exactly equal to 0.002 millimeters thickness. So tinning of mild steel plates is done mostly for the requirements of the food industry. Especially it is non-toxic element. That's why this is used for the food industry. But whereas in the galvanization process, zinc will be dissociation takes place and gives the toxic like nature. That's why galvanization is not preferred for the food industry. But tinning is preferred for food industry. So this is the advantages of the tinning method compared to the galvanization process. Now we see tinning objects. It is the tinning object. And after that we see the third process of the hard dipping, nothing but metal cladding. So that the surface to be protected is sandwiched between the thin layers of a coat metal and passed between the rollers. That means the finished product may be welded at the edges or riveted at some points. That means the coated metal has to be anodic to the base metal and only plain surfaces can be cladded. So this method is used for a coating of aluminum, chromium, nickel, duralium, etc. That means it is the example for a cladding of a duralium. So at the top and bottom we observe the aluminum clad sheets. This is nothing but rollers. In between we observe the duralium metal. Duralium metal is the base metal and aluminum is nothing but coated metal. Okay. So this metal cladding is also observed in the shellac nature. A coating of the thin homogeneous layer of the coating metal on the base metal is fused so that it is strongly binds permanently either on one side and both sides are passed through rollers under heat and pressure. That means all corrosion resistant metals like nickel, copper, silver, iron and platinum and alloys like steel nickel alloys can be used as a cladding materials. So base metals on which cladding is done are mild steel, aluminum, copper, nickel and other alloys. Duralium is very light metal alloys used in the aircrafts industry. That means most probably duralium is used because of the its let's say these are used in the aircraft industry. And the fourth method is nothing but electroplating. So from the title you can understand the coating of the coated metal on the base metal in the presence of a electricity. That's why this is called as a electroplating and it looks like a electrolysis phenomena. So electroplating is the process of coating of metals on the non-metals to change their surface properties, such as to improve the appearance and corrosion or chemical attack. That means electroplating is the electrodeposition of a metal by means of electrolysis over surface of a metals, alloys or non-metals. We see the source, that means direct current source, and there is a anodic area, that means impure copper, and there is a cathodic area, that means it is called as a object of a key. That means this electroplating is observed in the case of the especially current corrosion control. This electroplating is especially observed in the corrosion control phenomena. So the source coming out from the DC source, direct current source, at anode observe the copper coating metal, that means graphite or platinum inert anode, and at the same time cathode, that means article to be coated, and the presence of a copper sulfate solution, its own ionic solution. So electroplating of the copper or metal object, so that means nothing but the metal object to be plated is first treated with dilute sulfuric acid or dilute hydrochloric acid. That means the cleaned object is the made cathode of an electrolytic cell and pure copper plate is anode. That means copper sulfate and dilute sulfuric acid solutions are taken as a electrolyte. So when the current is passed from the battery through the solution, copper dissolves in the electrolyte and deposits uniformly on the metal object. That means the chemical reactions are nothing but anode. Copper undergoes a oxidation phenomena to get 2 moles of the electrons, and at cathode the residual electrons get by copper ions to get metallic copper. That means copper deposited on the base metal. So these are the reactions in the left side diagram. So what are the conditions for the electroplating of the copper over metallic object? So that means anode and coating metal is nothing but pure copper plate, and cathode base metal is nothing but metal object, and electrolyte is present in its own ionic solution like copper sulfate with dilute sulfuric acid, and temperature is nothing but 40 to 45 degrees centigrade, and current is nothing but 30 to 40 milliampere per centimeter square. So now we see what are the applications of the electroplating. Nothing but this process is widely used in the automobiles, aircrafts, and plating of the decoration, and this process is also used for refrigerators, jewelry, radios, cameras, typewriters, umbrellas, and watches. That means plating of non-metallic materials. We see gold plated watches, and copper plated mugs, and silver plated teapots, and silver plated goblets, and chrome electroplated taps. These are the examples for a electroplating phenomena. And finally, we see electroless plating. So from the title, we can understand this type process takes place in the absence of electricity and in the presence of the chemical reactivity, especially in the presence of a catalyst. So electroless plating is a technique of depositing noble metal from its salt solution on a catalytically active surface of the metal to be protected by using suitable reducing agent without using electrical energy. That means the reducing agent reduces the metallic ions to the metal, which gets plated with that catalytically activated surface, giving an uniform thin coating. So that means metal ions plus reducing agent to get metal deposited with oxidized products. So that means especially observed the electroless nickel plating having 3 steps as follows. The first step is nothing but pre-treatment and activation of the surface. The surface to be plated is first degreased by using organic solvents or alkali, followed by acid treatment. For example, the surface of the stainless steel is activated by dipping in the hot solution of 50% dilute sulfuric acid. That means metals and alloys like aluminum, copper, iron, brass, etc. can be directly nickel plated without activation. So that means non-metallic articles like plastics, glasses are activated by dipping them in the solution of containing tin chloride with hydrochloric acid, followed by dipping in the palladium chloride solution and drying a thin layer of fluid is formed on the surface. And in step 2, what happens? The plating bath nothing but consists of the following ingredients. Coating solution is nickel chloride solution, and reducing agent nothing but sodium hypophosphate. Complexing agent nothing but sodium succinate, and buffer is nothing but sodium acetate. And the pH maintain nothing but optimum range 4.5. So optimum temperature is nothing but 93 degrees centigrade. And we see in step 3 nothing but the pre-treated object is immersed in the plating bath for the required time, during which of the following reducing another nickel gets the coated over the object. So that means at anode what happens? Sodium hydrogen phosphate reacts with the water to give sodium hypophosphate. With the loss of the 2 electrons, oxidation takes place. At cathode, sodium hypophosphate converted into sodium hypophosphate. So at cathode what happens? Nickel reacts with the above loss of 2 electrons converted into nickel metal. So deposited on the base metal. So now we see what are the applications of this electrolysis plating. So electrolysis nickel plating is extensively used in the electronic appliances, and electrolysis nickel plating is used domestic as well as the automobile fields, automatic fields. So electrolysis nickel plating is also used for the domestic as well as the automatic fields. That means this application is used in making jewelry items. Electrolysis nickel coated polymers are used in the decorative and functional works. So electrolysis copper and nickel coated plastic cabinets are used in the digital as well as a electronic instruments. So we see the electronic instruments like circuit diagram and motherboard. So now we see electrolysis plating and the domestic wear also, and industrial wear. Okay, so this is about the electrolysis plating. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.